Hello, geometry students. This is Mr. Allen here, your geometry teacher. Today we are going to look at section 3.5, which is on parallel lines and triangles. Our objective today is to use parallel lines to prove theorems about triangles and define measures of angles of triangles. So the first statement that we're going to deal with today is the parallel postulate. This is probably the most contested postulate of all of the geometry postulates. This is what makes our geometry a Euclidean geometry. In other words, a geometry on a flat surface. And here's what the postulate says. It says, given any line and a point not on that line, there's exactly one line parallel through that point. So if we have a line L and there's some point P, then there's exactly this red line right here. There's exactly one line parallel to line L going through point P. There are other geometries where that is not the case. The triangle angle sum theorem says, and you probably already know this, the three angles of a triangle add up to 180 degrees. In other words, the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. I'm going to do a proof of this theorem. And so here's the information that we're given. I just basically took triangle ABC again, and we want to prove that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180. So typically I like to start off with the given information here. So what's given? Well, it's given that we have, the only thing that's given is triangle ABC, so that's given. Statement 2 says, construct line DE through point B parallel to AC. So what would give me the right to draw that parallel line? Well, that's that parallel postulate. The parallel postulate guarantees us that there is exactly one line that passes through that point that's parallel to the line AC. Now I'm going to go ahead and add the points D and E onto this line. Oops, my point D disappeared there. So that's line DE, and it's parallel to AC. Step 3 says angle DBE. Okay, that's that angle up there is a straight angle. That's the definition of a straight angle. It's a line, so it makes a straight angle. By the way, if it's a straight angle, what's its measure? Well, it's 180. So statement 4, I have that the measure of angle ABD, that's this angle here, plus the measure of angle ABC, that's this angle here, plus the measure of angle CBE, that's this angle here, those add up to 180. Well, why is that? I would say that that's going to be angle addition postulate, plus we know that that's a straight angle from the last step. So by angle addition of postulate, then we can conclude that those three angles added together are going to give us 180. Step 4, angle ABD is congruent to angle CBD. Okay, so I'm going to erase some of this stuff that I've done so far. So let's erase some of these markings up here. Oops, let's make sure we're back on a pen. Okay, good. So angle ABD, let's see here, ABD, that's this one, says it's congruent to angle CAB, that's this one. And then it says that angle ACB, that's this guy, is congruent to angle CBE, that's this guy here. It's kind of hard to see, but those are what we call, if we ignore the purple ones, just look at the red angles. Those, and I'll try to point this out here a little bit more. So do you see this line here, and then this line here, and then line DE? That's a transversal. So we call those alternate interior angles, and in this case, it's the theorem. By the alternate interior angles, if two parallel lines are cut by a transversal, then those alternate interior angles are congruent. So now I'm going to erase my work here again so that our picture's not too much of a hot mess. And then our final statement here, I said that the measure of angle BAC plus the measure of angle ABC plus the measure of angle BCA, which, by the way, those are just angles A, B, and C, is equal to 180. So how is that? Well, that's based on, oops, I'm on the eraser still. That's based on this statement and this statement put together. So this is basically just a substitution. And that's going to be from steps 4 and 5. So what I've done is I know that angle ABD is this angle. I can substitute angle CAB, that's this angle, in for that. Okay, so I guess what I want to say now about this proof, and that I've shortened this proof up a little bit. There probably should have been some more steps, but I've tried to clean it up a little bit to keep it a little bit shorter and to preserve some time. So let's go ahead and move on. Another way that you can see this proof, and I'm actually going to try to do this, this obviously is a proof, but just intuitively, if you have a triangle like this, and I just cut this out, and as you can see, I didn't actually cut it out that well. But if you take the 3 angles of this triangle and you tear them off, so there's one, you just need to tear off 2 of them, and then you take those 2 angles and you put them with that 3rd angle. Look what you end up getting. I'm putting that 3rd angle in there so you can see you get a straight line. So that's how you know the 3 angles of a triangle add up to 180 degrees. So let's use this in an example. It says using the triangle sum theorem, what are the values of x and y in the diagram? Okay, so you can see that we've got 2 triangles here. I'm going to focus on the one on the left. What do the 3 angles of that triangle have to add up to? Well, they have to add up to 180. So that means 59 plus 43 plus the measure of angle x has to be 180. So this is an algebraic equation. It's a 2-stepper. So let's go ahead and add these 2 terms together. So that's going to give us, I think that's going to be 102 plus x equals 180. And then what we're going to do here is we're going to subtract the 102 from the other side. And I think that's going to give us 78. So I think that x is going to be 78. Now let's deal with the triangle here on the right. First of all, would you guys agree that angle x plus angle y has to equal 180 because it's a straight angle? And if we know that angle x is 78, then that tells us that we could even write an equation for that 78 plus y has to equal 180. And therefore y is going to be 102. This is going to be something that's going to come back to play on our next theorem, but we'll talk about that later. And then finally, I need to figure out what z is. Well, again, that's another triangle. So I could take the 3 angle measures, which is 90 or 49, plus y, which we just found to be 102, plus z equals 180. Again, I have a 2-step equation, and I'm going to solve that. So that's going to give me, let's see here, 102 plus 49, that's going to be 151, plus z equals 180. And now I'm going to subtract 51 on both sides, and that's going to give me 29. So z is 29. So I've been able to find x, y, and I should have had z in here as well. So I apologize that I didn't do that. I found all 3. Okay, our last theorem for the day is the triangle exterior theorem, angle theorem. And actually, this kind of comes back to this problem here when we found y. And it says the following: the measure of the exterior angle, by the way, this would be the exterior angle of a triangle. That's when you extend one side of a triangle. You need to know that definition. You need to be familiar with. This is an exterior angle. So we extend a side of a triangle. That makes an exterior angle. The exterior angle of a triangle is equal to the sum of its 2 remote interior angles. So what that's saying is this angle here and this angle here, those are the 2 remote interior angles. Let me show you one more angle. I'll do it in blue. This angle here is not a remote interior angle. It's adjacent. So these two remote interior angles, they are the non-adjacent angles inside of the triangle. And the theorem claims, and we can prove this, that the measure of angle 2 plus the measure of angle 3 has to equal the measure of that exterior angle, angle 1. So here's an example. So it's kind of, we could work this out several ways. I'm just going to use the theorem that we have. And the theorem on the previous slide tells us that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. So angle 1 right here, this is that exterior angle, right? That's the exterior angle. And then what do we call these two guys in here? We call these two remote interior angles. And so we can find our answer here by basically saying that the measure of angle 1 is equal to 80 plus 18. So the measure of angle 1 turns out to be 98. 98, or you can do it 98 degrees. Okay, which I think is the measure of the human body, the average temperature. And our last example for today is a multiple choice question. So we've got a picture over here, and it says when the radar tracks an object, the reflection of the signals off the ground can result in clutter. Clutter causes the receiver to confuse the real object with its reflection, called a ghost. At the right, there is a radar receiver at point A. So over here's point A. And there's an airplane at point B. The airplane's ghost is at point D. So that information is bouncing off the ground and it's being reflected over there. So what is the value of X? So this is going to use that exterior angle theorem. So here's what we need to do. We need to look at this picture here, and I'm going to do it in yellow. We need to recognize that this is an exterior angle. And then we need to recognize that these two guys over here, that is a remote interior. That's not showing up very good. Let me do it in white. Here's a remote interior, and here's a remote interior. In other words, the measure of the, I'm going to call it angle DCB, that's the exterior angle, is equal to the measure of angle B, sorry, handwriting's not too good there, plus the measure of angle A. That's what the remote exterior angle theorem says. So what is the measure of angle DCB? Well, it's given to us in this problem that that's 80. What's the measure of angle B? Well, that's given to us, that's 30. And what's the measure of angle A? Well, that's X. I don't know what that is, but we can figure that out. We'll just subtract 30 over to the other side, and we'll get 50 is equal to X. So the measure of angle X is 50. So our correct answer here is B. And then that will be it for the day.